an R package that we developed and that two of your colleagues used in the previous talk. So as far as I know, you all have laptops with R and RStudio installed. And so I ask you to download this link here just to get the data and one script. So we're going to see how far we can go in this workshop, but basically I want you to do some calibrations of the GR4J model with no snow. And I want you to assess the impact of the calibrations, especially on different periods, on the simulations that you can do afterwards. So we are going to work with the lumped daily GR4G model. Did anyone write the link and try to download the data, or yes? Okay. So basically, I'm going to stop that. So you have this interface, you already know it. Just to help you to analyze data, we have several plots. So you know this one with the time series. You can zoom on it. You can really zoom as much as you want. And you can see the discharge values when you pass the mouse on the graph. And with a double click, you go back to the full period. So you have seen this plot. So here there is no snow, so we don't have temperature on the snowpack. So it can help to analyze the performance of the model. If you want to see what's happening in the model, you have this state variables plot in which you have the reservoir levels from production and routing stores. And you also have the diagram of the model. So this is a classic GR4J structure. And you can have an animation on which you see the arrows with an evolution of the different fluxes into the model. And on this table here, you have the performance in terms of Nash and KGE. So Nash is Nash Sutcliffe efficiency. It's a quadratic error that is used a lot in hydrology. And KGE is a more recent criterion that takes into account correlation, water balance, and variability of discharge. So basically it corrects some deficiency of the Nash. And all the criteria must, yeah?
Sorry, can we have this reference back?
Sorry? The link?
Yes.
So basically KGE and Nash are perfect with a value of 1. And the more they decrease, the lower the performance of the model is. And finally, what can I say? So here you can click on yes. If you go on this plot, you can click on yes, and you will have in gray the previous simulation. So you see one more curve in gray, and the new one is in orange. So it can be useful to see the impact of any modification. And if you want to keep some data or some plots from what you have here, you can click here on download as PNG. So you will have a nice plot already ready for you. And you have also download simulation as a CSV file. So it will produce the time series of several variables in a classical CSV format. So you have here only the period that you have on the screen. So that can be useful if you are curious about what is happening. Okay, so to obtain this interface, we just use a simple function of the RGR teaching package. So are you all in RStudio right now? If you don't say no, I assume it's yes. So I think you should have the RGR teaching package installed. I guess you had the information about that. If someone does not have it, please tell me now. You have it. Okay, so in the link that I provided to you, you have a zip file that you have to unzip, and it will give you data on this script, workshop Moscow.r. So I invite you to open this R file into RStudio. So double click on the R file should work fine. Otherwise, you have to open RStudio and then you do File, Open, and select the file. So I'm just going very quick on this file to explain what is happening. So here you have the selection of basin because I provided data for 14 basins in France. So here by default you have this one. You are free to select another basin if you want. So here we load the package RGR teaching, which is necessary for this exercise. We load the data. So every basin data is available in this file. Here we have a small lines to select the period of study. So for each basin we select 10 years of data, which can be different according to the basin, so that's why we have several cases.
Do we have to implicitly install the RGR teaching package?
Yes. So basically, if you are in RStudio here, RGR teaching. So here, you click on install, and you write RGR teaching. So, yes, so this one. It should be automatic. If you have any problem, please tell me. Yeah, it's ongoing. Yeah, okay. So of course you need access to the internet. So after we have read the data, we just prepare an object, a matrix, with all the variables that we need. So that's what you have here. You just see here that we have two lines, which we may modify if we want to do some tests that are kind of climate change tests. So if you want to mimic the impact of climate change, you can remove rainfall and increase temperature or potential evapotranspiration. So a simple way to do it is just to multiply the time series of precipitation and potential evapotranspiration by a factor. And so here the final function is for launching the interface. So basically, once you have RGR teaching installed, once you have the script open in RStudio, you can modify this code. So you select one of these codes here, any of them, and you click on source. It's here, source. It will open the interface.
Guillaume.
Yes.
What is that URL?
The link?
Yeah.
Он не включается, потому что он не понимает то, как там написано рабочая директория.
If you have any technical issue, I can help. It's installing.
There seems to be an issue with the set working directory.
Mm-hmm. Okay. I guess it's the same problem that Francesca had. So what you can do?
Yeah, you can explicitly put the full link to the file, right? To the
It depends on where you put it.
data,
Because,
right?
yes. Okay, they have to put it, you say that they have to put it like this, right?
Yeah, because I tried to get the directory path, but it's
Okay.
not.
Okay, so maybe you have to explicitly define the directory with this kind of
Oh yeah.
like this. I think it's so you just write the path here, but you can also do like this. You click on session, set working directory, and then to source file location. Maybe that's okay for you.
Yeah, same.
So it will just say I'm working in the directory where my file is.
Для того, чтобы загрузить данные по этим водосборам, нужно указать рабочую директорию с помощью вот этого или source file location, или там вот была setvd функция. Туда нужно написать, куда вы положили файлы из архива. Путь к файлам из архива. Он пишет, так себе как стилизм.
Did it work? Yeah. Seems so.
Не обязательно можно ставить, что было, только у меня директория ниже. Там ниже указывается лот, и в лоте можно поставить директорию.
Можно прямую ссылку.
Тогда все работает. Yeah, it works. It's okay.
It works, it's okay?
Yeah, yeah.
Okay.
Вот здесь писать, так писать, а перед этим ставить диск, папку и так далее. Вот сюда вот полный путь до этого файла.
Okay, so in the Word file that I show here, I propose a list of exercises that we could do. So obviously we will not have time to do each of them. So the first exercise was to understand the role of each parameter, but this is what we have done earlier with your colleagues. So basically, we have 4 parameters in GR4J. 2 of them are for water balance. So the X1, the production store, defines how much evaporation and how much runoff you will get from a specific rainfall. So you can see it easily when you modify the values of this parameter. And X3 is X2 is the exchange with other catchments. And X3 is for the routing store, so it's more about intensity of floods. If you have a low X3, you will have a more peaky reaction of discharge to a given precipitation. If you have a large X3 value, you will have a smoother evolution of discharge. And finally, X4 is about the timing. So it's a kind of delay. if you have a, you can see it if you do a zoom on it. If you have a large value, you will have a longer time response. If you have a small value, you will have a faster response. So basically what I would like you to do first is to assess the robustness of GR4J on your basin. So you have 10 years of data. I want you to do a calibration on the first 5 years and then do a simulation on the 5 last years. Here I'm talking about automatic calibration, so you are allowed to click the big green button and it will process the calibration for you. So basically you have to select here 5 years. You have to make a calibration and then you move the period here to go on the next 5 years. And what I want you to do is to discuss the robustness of these parameters, which means are these parameters still good for the second period? So you calibrate on the first years on P1, you validate on P2, and you check if the performance, so you have many ways to assess the performance in the interface, so you check if the performance is still good according to you. Yeah, to calibrate the model, I advise using KGE, but it's just a personal advice. So you can change the objective function here on the bottom left of the interface. So you will get slightly different results than with the Nash circuit. Okay, do F5. F5. Just, yeah. It happens when you do 2 clicks that are too close together. Or, so when one operation is not finished, then the screen does not like this. Package here, install, and then you write that you are teaching. If you are connected to the internet, yes, you have it. So it will take a few seconds to install. Did you manage to install the package? So once you have done this first step, I would like you to write down the parameter values and to do a new calibration on the second period. So the idea is to see if when you do a calibration on the second period, you have many differences or not. So now you calibrate on P2, you find new parameter values. Let's start something before. Sorry.
You can scroll. The Shiny.js library is installed.
Shiny.js. Oh. During the installation?
It did install, but Shiny.js successfully installed.
Oh. That is strange. So RGR was not installed. Okay.
RGR what?
RGR was not installed.
No, it was installed, but
No, RGR no. Because you also need RGR, but usually it installs automatically. That's... let's do that. Wow. That's the first time I see that. Okay, so now if we do
yes.
like this, line by line. Okay, so you do it automatically. Ah, shit. Okay, so
No, there's a warning. It's okay.
hey, it's not installed.
Successfully in fact, no. Okay.
No. How is that possible? It's installed, but we cannot see it.
It's installed.
Here, no. Oh, I don't know what to say.
Restart.
You can, yeah, you can do that. Close RStudio and restart it. Okay, so when you do this second calibration, you will find different performances and different parameter values. How much different they are from the first parameter set and values defines how robust the model is. So it all depends on the hydrological model we use, but also on the basin we use. So if you change the code of the station, maybe you will get different results than your colleagues. So what I want you to show here with this interface is how, with very simple manipulations of models and periods and data, you can already figure out how the models can be deficient for certain applications. So now what we can do, I think you said we finish at 30? Okay.
Well, now I guess we will finish when we are out.
Okay. So I just want you to select the driest year of your complete period. So more or less 1 year. If it's 10 months, it's okay. But just find the driest period. So you can assess that with the hydrographs. So you select a long period of low flows. So you should only have this on your plot, and you make a calibration of the model. Yes. We just restarted and it works?
Yeah, somehow. I restarted, reinstalled, and it works.
Okay. Mysteries
And
of,
the terminal worked.
yeah, mysteries of informatics sometimes.
Yeah. I noticed it with the latest version of our studio. There's some packages
No.
that are supposed to be installed.
It also happens that some packages are on the current, but only for one version of operating systems, not all of them. So when you have a new version, it takes some time to compile everything. So it may create some difficulties. If you want to have everything on the screen, you can look at Control minus. It will decrease the size. Control minus.
Oh yeah.
It's up to you what is the most comfortable for you.
Yeah. Great. Yeah.
Yeah, so basically I want you to select a very dry period to make a calibration. You will obtain
Is
new...
it complicated to select the right place?
To select the
The
period?
time window. It doesn't try to.
Ah, yeah. When you want to do very
Yes,
fine
yes.
things,
Yes.
yeah.
Oh.
Yeah, maybe we should add some date selection.
Oh,
I think it's quite dry. Yep.
run.
So here, if you do a calibration, you will find new parameters that may be quite different from the ones you obtained on the previous periods. Why is it the case? It's because you have only limited information on the basin. You have no information about floods here. You have only information about low flow conditions. So if you don't provide full information to your model, you will have a different response of the calibration because it will try to fit or to overfit these conditions. So once you have done that, you can keep the same parameters and double-click on the hydrographs to go back to the full period. And here, from that, you can assess the new performance of your model on the complete period, and you can also assess the global shape of the hydrographs. And don't hesitate to be curious and to visit the different panels, the different plots of the interface.
Like to split to the two data sets. This is only like about the time window, or
Yes, you can
So I
you can
just
do it
move
like
this.
this or by selecting a subperiod here.
okay, so
You
I
just
just
scroll. You just scroll and
can do like
yeah,
half and then analyze and okay.
it's okay. You don't need to be very strict.
Like
Yeah, if it's more or less half, it's okay.
Okay. Thanks.
And then you just have the calibration button that is on the top, on the bottom left.
The run one.
Yeah. So here you have the performances. In green means that you just calibrated on this criterion.
What is this? Gray?
The gray means that there is no observed discharge data.
There is no such strange thing. It's
Okay,
starting.
do F5. F5, it will load the page.
Here.
It happens sometimes. It's due to the way Shiny works with JavaScript and so on.
It was shiny.
Yes.
Because there was some warning about this.
Did you manage to make it work or not? Can I try just to see what is not working? We can run it line by line. Control Enter. So okay, so that doesn't work. It means that you have to how do you do that? No, this one. Control, no. Okay. Oh, it's here. Okay. So you need this command line, and you need to define this inside. Tu do Control Enter, okay. Seems okay. No. Ah. Did you modify something here? Okay. What's happening? What is the name?
Okay.
Name is missingdata.r data. we have data. Do that. Poof, 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 poof. That should be okay now.
Okay.
Don't forget to save the R file. One final thing that you can do now with the different parameter values that you have, especially the one on P1 or P2 and the one on the dry year, you can try to assess the impact of climate change with this parameter set. So for doing that, you will have to modify very slightly this R code. So that's located here around line 70, depending on what you have changed in your code. Oops, sorry. So there are two lines here around line 70 on which you can modify precipitation and temperature. So basically what you can do to assess very quickly the impact of climate change on hydrology is to modify the input. So it might not be the case for all the places, especially because in Russia you have many climate conditions. But in many places, we are going to have, of course, an increase of potential evapotranspiration, but also potentially a decrease of precipitation. So to be more exact, in many places it will be an increase during winter, a decrease during summer, but to keep the exercise very simple, let's say that precipitation is going to decrease. So once you have modified these two lines, you have to stop here the shiny application that is running. So you have a red stop button on this part of RStudio. You click on it, it stops everything, and you can source again, and it will use the new meteo data. And so what I suggest you to do now is to use the parameter values that you obtain from your calibration exercise to modify here the values of the parameters to those values and to see what it gives in terms of discharge. So you can analyze how close you are now from this so-called perfect discharge. So basically what we do with this kind of exercise is we calibrate the model on specific conditions that we know, P1, P2, dry period, and we assume that these conditions will still be the same in the future, that especially the model will still be correct in the future. So we apply the model with these parameters with new climate in the future, and now comparing more or less how the discharge from the model are compared to observation will give you a raw idea of how hydrology will evolve for your basin in the future. So here it's, of course, oversimplified, this kind of exercise. You don't have RCP scenario from IPCC, you don't have very strict results, and you don't make all the uncertainty assessments that you should do for a real analysis. But with just a simple test like this, you can already have an idea of what is happening. So since I did not write parameter values, I cannot do it on the screen, but I invite you to try a couple of things. Yeah.
I don't understand what means source. What is it? I don't understand.
Okay, so source is just executing the whole script.
And what is, so I have to just
So first, you had to stop the Shiny application from previous, So it stops the previous application, and now if you do source or run or whatever, if you execute the whole script, it will open a new one. And here you will have the new data, new input data, new meteo data. So now it's up to you to
calibrate.
No, actually, I want you to use the parameters from the previous calibrations. Because by doing so, you can assess how the simulations will be far from the observations. So you calibrate the model on certain conditions that you know, this is present, and then you apply the model on the future. So with minus 10% of precipitation, plus 25% of evaporation. So to do that, you have to use the parameters from the known period. And for example, if your simulation says that you have much higher flows or much lower or low flows, that will somehow describe the future conditions of this river. And basically with the input that I change here, you will get lower low flows and also lower flows. So it's a very simplistic exercise, but it gives some already idea of the sensitivity of the model to conditions, to input conditions.
And what is the difference between hydrological models which we can change?
So for this exercise, I just ask to use GR4J because it's quicker, but GR5J and 6J are the two models that I briefly talked about previously. So basically, they have 1 and 2 more parameters to calibrate, so it takes longer time, and they are supposed to be better for low flows. So we have a better descriptions of low flows in these models.
Okay, thank you.
So is it working well?
Not quite.
What is it?
I modified the application and operation by factor 2,
Oh, that's courageous.
which was like a bit extreme, but it shouldn't react in such a way. So if, everything went well.
When is the mistake?
Undefined columns selected.
Yeah. Can we do it line by line?
So I changed only these lines. Or should we start with
Yeah, from the beginning.
scratch?
Yeah.
Okay.
It's okay. That's okay.
Yeah. 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 Okay.
So that works. Too. Let's wait.
Okay.
And
So
so,
we had to touch
oh,
the page.
that's
That's
very
what-
reactive basin now. So I guess that if you use the parameters from the previous calibration, you will have some overestimation of
Everything.
flows.
Yeah.
For low
Right.
flows, you have a lot of evaporation. So
I mean, it's a kind of, yeah, for low flows, that's
ooh,
quite a lot.
So I don't know, maybe I will say a few words for conclusion.
Yeah, I think this would be
Okay, everyone. So I hope you could play around with the interface. So we could not do everything with a lot of time. So I'm sorry for that. But still, I hope I gave you a kind of overview of what you can do with models. So it's only a first step of what you can do with kind of models, and also with this kind of interfaces. So of course this package is free, and so you can use it for anything you want. If you are curious in the future, you can still play with it at home or during your studies. It's also open source, so which means that if you are kind of geek and want to see what is inside, you can access the code. You can even propose some modifications. We are open to that. And yeah, so I hope it gave you an interesting first step into modeling of climate change, and also the very important impact and question of calibration of models, and especially robustness when you transfer that to unknown conditions. So thank you very much.
Okay.